Our first speaker this afternoon is Skip Pizzi. Skip is Senior Director of New Media Technologies at the National Association of Broadcasters in Washington, D.C. His career has spanned the broadcast and digital media industries. He has worked as an engineer, technical director, and training manager at NPR, and later had held posts in audio production, media standards, and technical policy at Microsoft. He continues to act as a technology journalist, editor, and author. Skip serves as a chair of the specialist group on ATSC 3.0 system requirements, called S31, and is also vice chair of the parent technology group, TG3. He's a member of the board of directors for the Ultra HD Forum. Skip is a graduate of Georgetown University, where he studied electrical engineering, international economics, and fine arts.
Thanks, Wayne. Appreciate it. Welcome, everyone. This will just be a quick overview of what the value of ATSC 3.0 is, and also we'll talk a little bit at the end about the plans for transitioning from our current system to the 3.0 system to come. We have to give a bit of a caveat before any presentation we do on this, which is that we'll be talking about things, some of which are not finalized and are subject to change as the standards are completed. Although we're getting pretty close to that point, there's still some things that are up in the air and will be subject to some conjecture here and subject to change potentially later. We are, just to let you know that there is a due process that goes on, of course, as in any SDO, that is still in working its way through the process for finalization. We'll actually give you a snapshot of the current status of the ATSC 3.0 suite of standards in a second, give you a sense of the level of completion that we're at. Just to give you a background, as you probably are well aware, ATSC, the system, or what we're now retrospectively calling ATSC 1.0, which is current DTV standard in use in North America, South Korea, and elsewhere. It's been around for a while. And it certainly is something that is already ripe for improvement. When we look at what we're trying to do with 3.0, it's to make it quite different in terms of being more configurable, more scalable, more efficient, and hopefully more interoperable with other services. Certainly, though, adaptable and extensible for the future, so that we won't have to go through quite so many hoops when we want to continue to improve, because even though we think 3.0 is pretty forward-looking and up to date, come 10, maybe less years down the road, or certainly any time after that, looking back, we'll probably feel the same way about 3.0 as we do today about 1.0, and we'd like 3.0 to at least be somewhat more flexible and be able to be adapted and improved over time in a relatively easy or easier fashion. Think about it, where we were when 1.0 was developed. Many of our other technologies have dramatically changed and evolved since that time. Certainly, I doubt if any of us are carrying around those kinds of phones in our pockets anymore. Maybe a few of us still have flashing 12 o'clock VCRs somewhere in a rack or a cabinet under our TVs, but probably not using them very much. And certainly our digital communications and computing devices have moved along quite a ways since then. TV, not so much. So certainly it's time to do something and turn it into the next generation of digital. Our last conversion, of course, was from analog television to digital. This one is sort of from first gen digital to second gen. And look at what we're up against here. Quite a lot of new technologies that have come along And so it's only fitting and appropriate that television evolve to match. So if that wasn't reason enough, we can look at a lot of specific reasons about why this change is important, not just the obvious sort of market and context-based ones, but also some specific things about opportunities that television broadcasters would like to take part in that we really can't with our current system. And also consumers have demands for things that they can't quite get in their current systems, even the newest, say, over-the-top television systems, where it's very difficult to get live broadcast television, which is still the most in-demand content by category. Also, we have the issue of spectrum being challenged, as we've seen, and so we're trying to come up with a system that uses that spectrum more efficiently and works more robustly. And a final point is the idea of mobility. Mobile television wasn't really even a gleam in the developers' eyes back in the days of 1.0. And it certainly is something that's right up front in terms of our attempts to create a current modern system today. So lots of things have come along. And there are other technologies that are all out there that are ripe for the picking for use in this new service. So it's certainly a relatively important and easy process to take advantage of those new technologies, such as new compression algorithms and so forth. We've gone at least 2 generations of compression algorithm benefit. That usually means a doubling, so it's at least 2 doublings of ability since 1.0. So again, appropriate thing to think about plugging into our next-gen system there. There are a couple other business elements as well. In fact, we have a whole lot more competition, a whole lot more capabilities as broadcasters to manage multiple services, and as a result, we could use a higher quality or greater granularity and other improvements in our actual audience measurement. So that's one other element to think about. What we came up with was about a dozen different areas of technology that we could improve going from 1.0 to 3.0, and this is one way to sort of list them, and we're trying to achieve improvements in all of those areas as we move into this next-gen TV system we're calling ATSC 3.0. Now, for this audience, of course, consumers' benefits and advantages are key. And so in that respect, we're trying to both provide qualitative and quantitative improvements to free over-the-air transmission of television, high-quality television content, high-demand television content, in a way that works into the broadcast model. And although we certainly envision and utilize an internet capability, a broadband broadcast hybrid, a back channel, if you will, with the 3.0 television, it does not require that. 3.0 still works just as a straight unidirectional point-to-multipoint broadcast platform, just like 1.0 does, which gives it the advantages of being a very reasonably priced way to distribute high-quality content over a given region, over the air, and in a way that will now penetrate buildings better than 1.0, so reception over the air is actually going to be easier, and it can also work on devices that don't have large antennas, such as mobile, even handheld devices, and certainly give us the opportunity to still develop and distribute programs that a lot of people want to watch at the same time without network congestion issues that typically occur no matter how good your network speed is. there are for certain types of content that a lot of people want to watch at the same time in real time. Broadcasting is by far the best way to do that. That will remain that way. The infinite scalability of the broadcast model, it's hard to beat infinite. You can get good, you can get better, you can get faster, but it's really hard to get infinite. So broadcasting has always had that capability. We didn't even realize how much of an advantage that is until we compare it to internet distribution, for example. So that's one of the things that's being retained in 3.0 and then being added to by enhancements that can be also converged with the internet environment as well. So mixing internet and broadcast models together in 3.0 is a pretty powerful combination. Certainly for broadcasters, as we've mentioned, the greater flexibility, the ability to adapt and change over time. When you think about it, the wireless telephony works this way. Every time the wireless providers want to go from, say, 3G to 4G to 5G, really all they need is spectrum licenses. They don't need to go for regulatory approval for every change in their content or their format or their modulation schemes or anything like that. They just need spectrum licenses. And broadcasters don't have that luxury. We'd like to see that, and 3.0 essentially intends to provide that much flexibility, and we're asking the FCC to accommodate that in its regulation around 3.0. Just give us the license, give us the mask, and then allow broadcasters to evolve their own services, basically along the same lines that that wireless telephony, wireless communications, the way it works. We also, as I mentioned earlier, we want to have a system that's more robust, that works and to better penetrate buildings, and also can work to handheld and small devices without requiring large antennas. And finally, the extensibility that we've talked about, it's possible to do primarily because we envision this broadband connection as well for providing updates and so forth. So it's kind of a mix between the old fixed broadcast one-way model and the computers and internet world of having ability to update pretty easily over time. So the service models that we envision, this is just to give you one set of examples. Think of this as one broadcast station's capabilities to send at any one time or across a period of time these various components. So in that first set of, let's see, do I have a cursor here? No, I guess I don't. Over in that left-hand column, a program will run for a period of time that has obviously video and audio content, also has closed captions as is sort of required by mandate. And then those in the red are coming over the air. Meanwhile, other services could be delivered in the same time period by broadcasters, but those are traveling over the internet. And that broadband connection coming to the same box, the same receiver, the same TV, allows this hybrid model so that the user can select which one of those, say, two closed caption streams they want to watch. The one that's coming over the air with the content, and the one that's coming over the broadband connection. By the same token, they could also play along with an interactive application that might be coming in over the broadband. Now, if the user only has the broadcast reception and doesn't have the broadband capability, well, they wouldn't get those two things in the blue, but those are enhancements, additional. They'd still get the main content through the audio and video and closed captions in the red. The next program might not have anything in that second column. It's just got the regular AV and closed caption content coming in over the air only. And on the next the third column there, you can see an application is the only thing, an enhancement application that comes along, the only thing that's coming over the broadband. And then in the fourth one, you see that actual separate video or audio content and that can be chosen, say a different dialogue language in the audio case, or additional video content that might be something like catch-up TV or any other options that are available could be coming in over the broadband. And note also, an application could actually come over the air in this case. And so in this case, if the user didn't have the broadband connection, they could still get the advantage of being able to, if they wanted to, utilize that application as well as get their AV and closed caption. They wouldn't have the access to the video and the secondary video or secondary audio in that case. And of course, somebody that has both broadcast and broadband connectivity gets all those choices. So that gives you an example of the what we're talking about with the so-called hybrid model of broadband plus broadcast. Now, just to give you a sense of where we are in our process, this has been going on for a while. We've been planning this for a good 5 or 6 years. We developed requirements over a period of a couple of years, and this was an international process where we met with a number of other broadcasters and even other consumer groups around the world, and put together a good several dozen ideas on different requirements and distilled them down to about, as I said, 8 dozen or so specific areas. And then the standards were developed, are still being finished, but for the last 4 years or so have been under development based on fulfilling those requirements. And we hope to see products starting soon, certainly in Korea, where the service is being launched later this year, 2017. We're seeing the earliest products flow out now. You see a few of them here on the show floor this year, and we'll certainly see a lot more of them at this show next year, as we expect the US or North American launch to happen starting in 2018 and beyond. And for finally transition ideas, what we did the last time around in the US was what we call simulcasting, where a channel, WXXX in this case, was given to, a broadcast station, I should say, was given 2 different 6 megahertz channels in the US to broadcast, one of which was analog and the other which was digital. Now, if we were going to try to do that again today, we'd have our digital ATSC 1.0, and that broadcaster would get a second channel to do the 3.0. Unfortunately, there is not the spectrum available to do that today, and we're facing an incentive broadcast auction where channels availability is going to become even less in the next few years, probably. So this is not a model that we could use this time. So a different approach might be the way to go in the US. By the way, I should mention in Korea, that is the way they're doing it. They've been given new spectrum to use in the 700 megahertz UHF band for specifically ATSC 3.0 services. So those services will be launched, and traditional ATSC 1.0 service will continue for some period of time. They have a roadmap, though, where they even where they're shutting off the 1.0 services, and will add more 3.0 services in place there. So they're doing the simulcast model in South Korea. In the US, though, we're going to have to come up, because of the fact that we don't have the spectrum available, we're going to have to use something where, let's say there are 2 channels, 2 stations rather, in a market, and this would, obviously there's usually more than 2, but just to keep it simple for the explanation, let's say there are 2 stations. They each have their own 1.0 services in place now, of course, currently, and the way it would work going forward would be those 2 stations would cooperate in that they would carry each other's, one of them would stay at 1.0, and they would each carry as a multicast each other's content, and the other station would go 3.0 and do the same for 3.0 in a sort of a comparable manner, and so that they would have a capability to share each other's content, one delivering 1.0 service, but with multiple broadcasters' content on it, and the other doing the same for 3.0, sort of a reciprocal arrangement. Now, this is not technically allowed today by current regulation. So part of what we've already asked the FCC to do is to allow their rules to be amended to provide this capability for broadcasters to carry each other's content in this way, to allow the broadcasters to do their own sort of voluntarily business broadcast managed transition without any regulatory management of it, but just the permission to allow broadcasters to do this. So that's the idea for the channel sharing model of transition over a period of time. Ultimately, we would assume that once enough 3.0 receivers were out there, that the 1.0 services could be sunset, and then everybody could go back to carrying their own stuff. And this could be a market-by-market kind of a transition, so happening over time, say starting in the larger markets first and percolating out. The other element, and this is a piece of potentially any transition, is the idea of providing some sort of receiver subsidy or seeding, as it's called. Last time, you may recall, in the U.S., the federal government issued these vouchers that allowed folks to keep their own old TVs if they didn't want to replace them with a new TV, or they didn't have cable service that was going to, or MVPD, cable or satellite TV service, that would allow them to do this without needing any conversion. If they wanted to just get off the air service but didn't want to get a new TV, they could get a cheap set-top box and use these vouchers to potentially reduce that cost further and bring it down to perhaps almost nothing. And this way, they could then they wouldn't be orphaned. No one would lose television service. In this case, the government is not likely to provide that kind of a subsidy, so the industry may have to do it themselves. And so we realize that this will require good collaboration between broadcast and consumer electronics industries, and it may require a subsidy, probably almost certainly would require some sort of subsidy from one or both of those industries. So we see that could be even a piece of the channel sharing model, just to be able to accelerate the transitional period and allow things to get back to a full 3.0 only kind of transmission model and not have to have this channel sharing. Because obviously, when you do that, you split essentially in half, if not more, the bandwidth capacity that's possible. And the 1.0 services would have to be squeezed into these existing, what we're calling lighthouse stations, the ones that would stay 1.0. And because that also means they would have to use MPEG-2 video compression and AC3 audio compression, that you'd have limits as to how many services you could actually carry without quality really being degraded. So this is a challenge. You don't want to have to do this for any longer than necessary, and the receiver seeding at the end of that process is something that you could do to get it to move forward and not take forever. So that's our transition idea for the North American market at this point, and we'll see how well that works. Summary there, this 3.0 is not a backward compatible system to 1.0. That allows it to really do a lot more, but as a result, it's got to be good enough and be different enough to enhance or to make folks, both broadcasters and consumers actually, motivate them to make those conversions as necessary. It certainly makes us puts us in a place that acknowledges the current world that we live in, and we are also trying to be as efficient as possible with broadcast spectrum, and change regulations as necessary to make this a more modern system, and certainly we would hope enhance the business for both broadcasters and consumer electronics going forward, as well as be flexible to future enhancements beyond. So that's where I'll leave it. Turn it back over to Wayne, and then we'll take questions at the end after the other presentations. Thank you.
Panasonic.